In this video, we're going to talk about the topic drawing polynomials. And in this topic, there's going to be two objectives. The first objective, I'm going to jump down here quickly, is to write in factored form or write a polynomial in factored form if given the graph. So, if given a picture of a graph, can you write it in factored form? So objective one is going to be a little bit of a review because we've talked about that before, but it's still important to practice because the new learning in this topic is objective 2, drawing the graph if given the equation. And so I'm going to break up videos. I'm going to do objective 1 in this video and then talk through objective 2 in the next video. In order to do objective 1 though, I'm going to go back and talk more in detail about the idea of multiplicity. So a sub-objective of this is that I can identify multiplicity in polynomial graphs and equations and apply to graphing. And we've talked about this in brief detail, but again I want to talk about a little more detail. I want to talk about the different types of zero solutions and x-intercepts and how they relate to how the graph of a polynomial looks and what happens at those roots or zeros or solutions. And remember that a zero is where the graph goes through the x-axis, but also it could be where the curve of the graph touches the x-axis. I'm going to write touches, but I'm also going to write bounces off as well, because I've used both terms before. Bounces off. So this brings us to the idea of multiplicity, which just means that the same solution exists multiple times at that root, or solution, or zero, or x-intercept. So in this graph to the right, there's two solutions. I know that because the x-axis here, they hit twice, and we've talked about this. They hit 2 times, and so this particular graph is a zero with a multiplicity of 2 at x equals -2. Because I know that it has a multiplicity of 2 because it does this action right here. It approaches the x-axis, and then bounces off. So I know that it has a multiplicity of 2 because 2 solutions exist there, the same 2. It's -2. Here it goes through, so it has a multiplicity of 1. We've talked about that before. And we've also done this skill as well, the 0 written as a factor. So this is the root, x equals -2. The factored form would be x plus 2 squared. And that's important because that's going to help us write it in factored form, and that's our first objective, to write in factored form. Over here, this solution is x equals 3, and it is just written as a factor as x minus 3. Remember, the signs change. It's a power of 1, but I don't have to put the power of 1. So that's just a little refresher on multiplicity and why it's so important, because it does affect our graph itself, and it does affect the roots and the factors, and especially when we write in factored form. We have to identify how many times each root exists. So let's go through. I'm not going to cover this. Let's move on to an example. The actual objective, writing factored form of equation if given the polynomial. So writing factored form of writing factored form of a polynomial equation if given the graph. So if I'm given this graph on the right, I'm going to do 2 examples just to really show my thought process as I'm approaching it. The first step, and I've kind of laid it out here, the first step is to identify the solutions with multiplicity. So I can circle them on the graph. If I look at it and visually analyze the information, there's a solution there, and it looks like there's a solution there. This one looks a little different, and I'm going to talk about why, but we'll still approach it how we've done in the past. So I'm going to write x equals, the first one it hits at 2. But again, it bounces, and so I know it has a multiplicity, an even multiplicity, and a multiplicity of 2, so I have to identify that. And I can write that there as well. So I identified the solution, I identified the multiplicity of, and then as a factor I can write it as x, it's a positive 2, so I have to write x minus 2 squared, because again, the multiplicity 2 identifies the power in factored form. And so I've done the first solution. The next one is x equals 4. So at x equals 4, it goes through. And so we've only talked about it goes through And if you notice, it kind of does this little wiggle action. It doesn't go straight through, it kind of wiggles and then goes up. And so the point of intersection right here is wider than what we've dealt with. It's still odd, it's an odd multiplicity, but it's technically a higher multiplicity than 1. It's probably a multiplicity of 3 or 5. And what that does is it just stretches out that intersection point, makes it wider. But for the purpose of this lesson, I care about that you know that it's an odd multiplicity, and we're going to use the multiplicity of 1. And so if it's factor form, then it's x to positive 4, so it's x minus 4, and I don't have to raise it to a power because it's the power of 1. So I've done the first 2 steps. I found the solutions and identified the multiplicity, and then wrote them as a factor. Now, the degree, and we've talked about the degree. The degree is how many solutions exist on the x-axis, or how many solutions exist in general. And I find that out by adding up the powers here. There's a power there, and technically that is the power of 1. So I add up 2 plus 1. So this is going to be degree 3, or x to the 3rd. I'm going to put that in parentheses, x to the 3rd. It's degree 3. So I've identified the degree, and then finally the direction. And direction just means what is the end doing? Is it positive or negative? And the end over here is going up, so I know that this graph is positive, or this equation is also positive. And so finally, to write the equation, I write y equals, in factored form, x minus 2 squared times x minus 4. And I'm done. I can identify that it's positive because I don't have to put anything in front if it's positive. Now, if it was negative, I'd have to write minus. So, let me go down to one more example just to really talk through this concept. Another I do. In this case, the first step is to identify the solutions. So I have 1, 2, 3 this time. So I'm going to write x equals negative 3 with a multiplicity of 1 because it goes through. X equals negative 2 with a multiplicity of 2 because it bounces, so it's even. And then x equals 1 with a multiplicity of 1 because it goes through. If you notice though, and this is more pre-calculus, here it goes straight through. Here it does that wiggle. And so technically, this power here is still odd, but it's going to be higher than 1, probably 3 or 5. But for the purpose of this class, it's multiplicity of 1. So I've already identified that. 1, multiplicity of 2, multiplicity of 1. As a factor then, it's going to be x plus 3, because it's a negative 3 as a root, or a solution. And it has a power of 1. I don't have to put it if I don't want. Down here it's x plus 2, with power of 2 because it was multiplicity of 2. And then finally, x minus 1, power of 1. So then for the degree, I add up all the powers. 1 plus 2 plus 1, I can put little plus signs there to remind myself, is 4. So the degree 4. And the direction, you look back at what the tail is doing, it's ending going up. So I know that it is positive. If you notice, both endpoints are going up, and the degree is even, so I also know that this is even as well. And the one prior to this, one ended going up, one ended going down, so I know that this one was odd. And it makes sense because the highest power is an odd number. So, at this point, go ahead and try the you-do problem. Pause the video, try the you-do problem. And then with the you-do problem, I want you to also identify if it's even or odd. And then your final answer, you should come to the equation, y equals your factored form. And please keep in mind for this solution right here, I've already kind of identified it. It looks to me that it hits at 0, so that's going to affect your factor in a way we haven't talked about in the 2 examples. But if you go back to your previous notes, you should be able to figure out what the factored form of a solution of 0 is. point you pause the video and tried this on your own, and you've entered your answers into the Edpuzzle questioning. And I'm now going to show you the work, so if you didn't get the correct answers, you can check your work with mine. So I'm going to have, I've already identified by circling, and that's my first thought process, is where does it hit the x-axis? So I know that it hits at x equals -2. It's bouncing off there, so it has a multiplicity of 2, and I can identify that there too. At x equals 0 in this case, and it's also bouncing, so it has a multiplicity of 2. And then finally, x equals, it looks to be 1, and it's going through, so it has a multiplicity of 1. Now, this is that part of, well, not quite yet. This first factor is easy. X equals -2, so now it's going to be x plus 2, raised to the power of 2 because of that multiplicity. This is where, remember when, if x equals 0, the solution is 0, then the only factor that works with that is a single x, either being multiplied by a number or just x by itself. So I could have something like 2x, and because of that multiplicity of 2, it has to be squared. But if you remember, it has to be just an x or a number being multiplied with it, because the only number I can put into this x to make this factor 0 is 0, because 2 times 0 is 0, or anything times 0 is 0. And 0 raised to anything is also 0. And then finally one more, x minus 1 to the power of 1. So I'm done with that. The degree, 2 plus 2 plus 1 is 5. The direction, it's going, in this case, it's going down. Hopefully you saw that. So it's negative, and it's even or odd. One endpoint's going down, the other one's going up. So in this case, it is odd. Now, the equation to finalize it, y equals, and I have to write negative now because I identified the direction is going down. And it's parenthesis x plus 2 squared times 2x squared times x minus 1. To clean it up, I always like to put the single factors by itself, so negative 2x squared times x plus 2 squared times x minus 1. I like having the binomials next to each other, so that would be my final answer. Raise your hand if you did not get that so we can talk about it.